broadcasting live from our New England studio. Solutions Review is proud to showcase Broadcom in the Solution Spotlight, an inside look at enterprise technologies.
I'm Doug Atkinson here at Solutions Review, and welcome to the Solution Spotlight featuring Broadcom, and focused on how to de-risk your cloud migration, 5 tips for proactive network observability. If you're planning a cloud migration, you're also in need of a visibility plan that bridges the gap to public clouds, SaaS applications, and remote users, which native cloud tools can't see. So today we will explore how network observability provides critical visibility to de-risk your migration and showcases how to validate success using objective metrics for applications and network performance. And to walk us through the event today from Broadcom is Alec Pinkham, Product Marketing for AppNeta. Alec, thanks for being with us.
Thanks for having me, Doug.
Well, I love conversations like this because we all know the first movement is get to the cloud, but there are always downstream implications for that initial, it's like the first act and then the reaction and the subsequent actions. And this is a great topic for us to be able to explore with you. Before we get started, though, you've been at this a while. Why don't you give us a little bit of background about your role at Broadcom and a little bit more about your journey?
Yeah, for sure. So I've been with the AppNeta product line for about 11 years now through the acquisition of Broadcom a few years back. And so we've spent a long time just getting the network visibility part right. We had a little bit of a foray into application performance management as well, which is when I originally started, but I have been in the network space for 10 of those 11 years. And before that was really focused on engineering and quality assurance for more technical type of software for SCADA, HMI, more machine level code. And so it's just been a little bit of a transition from kind of the hardwired world of manufacturing into the world of the cloud. But networks are important regardless of where you are. So always been a kind of a through line in my experience.
Yeah, so I'll set everybody's expectations because Alec is a proper expert over and above everything you're going to see with regard to Broadcom and AppNeta. So if you have any questions whatsoever for Alec, by all means submit them. I'll take them in here and hold them back while he walks through a presentation and a little bit of a demo. So you're going to get a kind of a under the hood look at how the software works. And so I'm going to turn things over to you now, Alec, and I'm going to let you take it from here, but give me the high sign when you're wrapping things up, and I'll jump back in and we'll do a little Q&A.
Perfect. Thank you, Doug. All right. So before we dive into the main topic today of how we de-risk a cloud migration, we sort of need to understand where, like the environment that we're operating in today. And so over the last years, decades, we've seen this rapid move to public cloud. But now the conversation starts to shift, right? We're seeing a significant repatriation into on-prem and private cloud workloads, which has really left us in a hybrid scenario for most organizations, either from a hybrid application scenario where you have applications calling out to services in a different cloud environment, or just located in different geographies for resiliency or to serve different customer bases, right? One of the things about Broadcom is, as you are all aware, we bought VMware a few years back. And so VMware Cloud Foundation is one of those private clouds that's kind of leading the way in there. And the focus around this repatriation movement is really around agility and scalability from the public cloud world, but then with the privacy and kind of control of on-prem. And this isn't a talk entirely about, the move to VCF. It's one of the most significant cloud migrations we're seeing today, but it really applies to all types of cloud migration. And the idea of moving apps from internal environments to externals right? Internal environments where you own maybe all the way from the physical infrastructure all the way up to the application. And you're moving those into a public cloud scenario where you don't have the visibility and control, or vice versa, where you're moving from a public cloud area where you've had maybe some additional flexibility and resiliency of the public cloud, and now you're trying to replicate that on-prem. And so the reality is migrating to any cloud environment, either going up to public or back to private, it's a complex project, right? While the destination offers benefits, one way or the other, the journey is really where we see a lot of the pitfalls come in. And an effective migration planning requires more than just moving the virtual machines and the applications and the services, right? It requires kind of deep insight into the dependencies of each application. And that includes the networks that they transmit data over, as well as the infrastructure they're sitting on. And so one of the things we see with migration specifically is that it's very difficult to prove the success of a migration if you don't have data from beforehand, right? If you don't have good objective data, as Doug mentioned earlier, and as I'll go into with our tips of, if you don't have a baseline beforehand, then it's very difficult to prove the success of the migration later. Everyone knows, especially in networking, but cloud operations will probably see this as well, is the last thing changed is usually the first thing blamed. And sometimes that's right. Sometimes it is, the latest change is the problem that eventually hit to a user. But oftentimes it's on the cloud or the network or the operations teams to prove that they were successful, not just an assumption that they're going to be. And so that's where most organizations kind of hit a wall, whether you're moving out to the public cloud or back, right? The gap between the two is really the problem. And so the reality is, if you look at modern IT today, the term kind of single environment it's a fantasy. Like, you don't have one environment anymore. You have multiple. You're on a hybrid environment, or your applications span multiple clouds, or you have reliance on external parties like SaaS apps, or you have users that are no longer sitting in the network. They're in home networks like I'm sitting in today, or they're in coffee shops, or they're actually transiting on, airplanes and things like that, where you're connecting in, and their user experience is the thing that you have to be kind of tracking, right, the whole time. And so most monitoring tools that we talk to, especially those that are native to a specific platform, are really good at monitoring that part of the platform and within kind of their walls, so to speak. And they can tell you about the virtual or the physical infrastructure that are sitting on you, some of the health of the devices or the applications or the services, but their visibility kind of stops at the perimeter. And so when you're just using a kind of a passive discovery tool or monitoring tool, you're really not going to see that end-to-end path. And that's kind of what we're thinking about today. And so this is the critical gap in public cloud, where you have probably no ownership. Even if your applications integrate with services like Office 365 or ServiceNow, right? You have visibility of your services, but not outside of that. With SaaS applications, you likely have very little visibility, only within your four walls of your data centers and offices. And then once your traffic actually transits out over the wide area network, you're not going to have any visibility. And the last piece here of remote users or branch offices, you're often going over an ISP connection, even if it's in an underlay for an SD-WAN type setup. You're not going to be able to look at that middle mile between the applications and the office where that user is sitting, whether it's a home or a corporate office. And so the description of this event really talks about de-risking the cloud migration. And what we're here to talk about is one of the tools that Broadcom has that can help you do that. And the tool is AppNeta. And AppNeta is the product that I've been working on for a number of years. And the gist of AppNeta is that it's focused on looking at the end-to-end path of a user's traffic to understand their experience with an application or a service, but it's from the end user perspective. And so we're actually instrumenting either the user's laptop or putting a device, virtual or physical, into their office environment or their data center, and then sending active traffic over the network to understand the application and the network health specifically from that user's perspective. And so instead of going what we usually term as outside in, where you're monitoring from a cloud location to a general area, so maybe a cloud location to Boston or to Seattle, where you get a general idea of the connectivity, but you're not actually transiting the correct ISPs or the specific network path that your user might be taking, it becomes a lot harder to understand where their performance falls down, right? Where's the problem when issues occur? If you do it from the inside out and you do it from the end user perspective, then you're transiting the actual network paths that they take to get to their applications. And if you do this actively, you can actually rewind the clock when they have an issue and they've told you at 2 p.m. on a Monday that they have a problem. They're probably talking about something that happened minutes or hours earlier that they eventually got frustrated enough to open a ticket for. And so if they haven't opened a ticket for a number of hours and then you start troubleshooting through passive type of monitoring, then you're not going to actually have the data from when it happened. And so you're not going to be able to catch something like a route change or a data loss spike or jitter that happened specifically at the time that they were requesting. And so the core that I want you to take away from just the basic idea from AppNeta as we go through these is that active monitoring, continuous monitoring, that is the way that you can get better data, especially in a cloud migration scenario where you're changing things, probably not all at once, but over time. And so understanding what before and after is gets a little bit difficult. And so we want to be able to kind of parse when we have started the migration versus when we've ended the migration. Have we impacted end user experience to a degree, right? It should be equal or better when we're moving from one cloud to the next. And so let's get into our tips, and then I'll go through each. I'm actually going to go through the demos as we go because I felt like that was an easier way to keep attention, but also kind of show you things as I'm talking about that instead of having to rewind. And so the 5 tips I have are right out here. So extending visibility, right, and bridging the gap beyond what traditional tools can see, right? So public clouds, SaaS applications, remote users. That's really what we're talking about there. Then we're going to establish performance baselines before the migration to identify things like bottlenecks and improvement areas that we can fix along the way or that we can prove that are better after the migration. Then I'm going to focus on proactively monitoring end user experience. And that's really about that active technology that we're talking about. And this is during migration, right? Because we want to be able to rapidly resolve issues as we go. Then we're going to validate migration success using objective metrics for application and network performance. So looking at some maligned indexes like AppDex scoring, but ones that allow you to understand over time, is there a fundamental shift in what the performance of this application is? And last, we'll use synthetic transaction monitoring. So continuously simulating user workflows and use those to proactively kind of detect slowdowns. Okay, so with those, we'll go right into tip number 1. So extending visibility and bridging the gap, right? The biggest ongoing risk to your business, your organization is really the stuff that you can't see. And so when we're talking about private cloud or public cloud, the environment doesn't exist in a vacuum, right? It's part of an ecosystem, either internal or external. You're going to have your internal networks that, for me at home, is my computer, my wireless, and my last mile ISP out the door before it can get to any of the Broadcom servers. Right? If you have an office environment or a data center environment, you probably have tools that look specifically at those devices, virtual or physical, but they probably don't go out into the WAN or don't have the connective tissue. And even if you have a direct connection between the two, you're often handing it off to a third party to actually do that. And more often than not these days, you're not getting an SLA for performance. You're getting an SLA for capacity. You're getting an SLA for an overall traffic volume, but you're probably not getting one for the end-to-end performance of an application that rests in that data center, right? So we want to extend visibility beyond the perimeters of those kind of islands or silos that we have today. And this is where AppNeta kind of fundamentally helps, right? It's built to monitor the entire journey that an application takes or that a user takes to an application. And it's not just a segment within one of those silos, right? We're strategically deploying those AppNeta kind of lightweight monitoring agents across a bunch of different environments. So your internal environments, so your LAN, we can have global monitoring targets or monitoring points that are put into cloud environments. On the public cloud, you can also put them within your data centers. And so being able to do all that is going to get you some of the visibility. Now, we're mainly talking about AppNeta today, but one of the things that I want to say is within the data center, you can still use other Broadcom tools like DXNetOps to understand the topology of your devices and all the dependencies they have. And AppNeta data is basically piped right into that so that you can have the visibility and the end user experience data kind of put on top of the full network topology that you have within your data center or within your corporate offices. So there's a kind of connection there, but we're focusing mainly on AppNeta today. One, it's my expertise, and two, it's one of the ways that we really work well with things like VCF for private cloud repatriation, or the move to public cloud where you're actually giving up control and visibility to a third party and hoping that their tools can actually give you the visibility you need. So when we talk about clouds, and when we talk about SaaS apps, and when we talk about the traditional network tools, right, it usually provides the visibility into one end of this spectrum. So on the very far left, maybe it's the office, the branch environment that you have visibility into from traditional tooling. Maybe on the right-hand side, it's clouds, data center, if you own it. But particularly, we look at these as kind of the four fundamental error domains that we're trying to get visibility into for any type of application traffic. And we talk about applications because those are the ones that typically write the support tickets of, I have a problem with X application, right? But that's not what we're mainly relying on to understand the performance, right? It has to be transmitted over a network. And so the network is actually a fundamental piece of this that we don't always have the visibility into. So these error domains and the fundamental ones that we always want to look at are the user environment on the left, the last mile ISP or the last step before, whether that's a third party, whether it's over SD-WAN, if they're an underlay or an overlay that we can look at. And then the transit peering network, basically anything upstream that we're peering with that you see on traceroute or the actual route between application and user. And then the application environment, whether that's in your data center or your cloud, right? So understanding these kind of four error domains, it's just a fundamental way. It's not every path, network path between user and application is going to be a little bit different. But this starts to lay the framework for us to understand where. And where is really important in a root cause analysis, journey. We're looking at where the problem is. And so in this one, we can see the actual route diagram from a path between Denver and a Google API for BigQuery. And you can see we have a couple distinct places. Again, you can see that we have our AppNeta demonstration. That's just our demo environment. So that's just taking the name for the organization. So that would be Broadcom for me. That would be, Solutions Review for Doug. The next step is going to be the ISP out the door. In this case, we can see CenturyLink. After that, we're going to look for the peering provider. That's level 3. So CenturyLink is peering with level 3 to actually get your data to Google. And then within the Google environment, we can see that over a certain amount of time, there are multiple endpoints. The thickness of the line is going to show how often we're taking that route within the time period. These are usually defaulted to 10 minutes, but can go all the way up to 30 days of data. At the bottom here, we're looking at the actual hop by hop of a single path that's actually triggered a diagnostic. And a diagnostic is essentially just showing us the hop by hop data, right? And so when we're doing root cause analysis and we're trying to identify where the problem is, we're looking for a spike in a specific metric. So in this case, on the fourth row, you can see the data loss spikes to 10.43. You can also see on the third row, we go from 1500 MTU to 1492. You can see latency spikes later in the path. So understanding which metric is being affected is going to help you understand where problems are really happening for a user. And so when we're doing root cause analysis, we need all of this information, right? We need the end-to-end coverage, right? It's required because if you're missing a hop or an entire network, or in this case, an error domain, it means that you're not able to pinpoint where an issue is, right? If it's an application or network correlation, we need to understand the impact on users, not just the traffics and flows. We need to understand which ISP is it. If you're a centralized IT team, you probably don't know which ISP is serving every office around the globe. And then we look at things like capacity and the core network metrics. And so with that, we'll actually jump into the first demo. And so what I'm going to be showing you here is really focused on visibility. So if we're looking at visibility, and I'm, in this case, looking at something like Teams, right, I'm able to get an SLA for performance based on the violations of our alert profiles. So alert profiles is basically a fancy way of saying we have alarms that are triggering for a specific type of data loss or jitter or latency, one of the network metrics that we're tracking. And we're looking at that and saying, okay, this much data loss is going to impact performance, and so we're gonna make sure that we're actually reporting that. And then over time, we're reporting that across different locations. So in here, you can see Zeiss, you can see Vancouver, Ashburn, Virginia, and Seattle, Washington, just as some examples. And you can see generally our performance is good. Vancouver has started to trend in the wrong direction over the last few days. In this example, we also see that Zeiss has been bad for a very long time. So maybe our sphere of influence is Zeiss in Vancouver. Maybe it's just Vancouver, but it's understanding that if we have the visibility, not only for an up-down availability type of thing, if we can see performance, and you can see this, right? We always say slow is the new down, right? Down doesn't happen very often. You heard it today with Cloudflare. You hear it every once in a while with AWS, but it makes news when things go down. Oftentimes, things just get slow, right? Performance suffers and some user is impacted. And so that's what we can see here with the violation on performance thresholds. We can still reach the application, in this case, Teams. We can still make sure we can connect to it, but we're violating on the performance threshold. And so when we have the visibility for seeing it, we can actually create these types of SLA charts to understand not only where we're being impacted, specific users or locations, but we can also understand what's being affected. In this case, you can see that for Zeiss, connectivity was only 3 minutes of downtime. Data loss was 690 hours. So this app probably just isn't accessible through this. So that's probably a bad example. But down here, you can see in Vancouver, connectivity is 39 minutes. Latency is impacting performance 314 hours, right? And this is going to be over the past 30 days for this application. Okay, so that's our first demo. I'm going to switch back and we're going to go into our next tip. Next tip. Establishing performance baselines, right? So it's kind of the most fundamental step in de-risking cloud migration is establish a performance baseline before you move anything, right? It might sound obvious, but it's often kind of overlooked because we're being forced to migrate by someone else. We're trying to rush into this migration. Probably not. We're probably planning a lot of it, but we're rushed into the actual steps of it and focusing on how we're going to accomplish it and not really focusing on what the end result should impact. Right. So without a baseline and if you're attempting to validate success at the end and you define what success looks like, you should define it by some of these metrics to understand what it actually kind of is going to impact at the end. So we use synthetic monitoring. We talk about this a lot. It's synthetic from both a network perspective and a web app perspective. We're doing transactions to test whether or not the kind of overall end user experience has changed. Right. So the goal of this phase is really kind of two phase, right? We're basically identifying bottlenecks in the current environment. And then we're like defining good performance for not only an application, but from different geographies. Because latency networks, it's going to be different depending on where you are. Some apps are better than others at geolocating and kind of being close to users. But, understanding what does good performance look like is really the core of this. So how do we do that? First, we want to measure experiences. We want to understand what the key apps are, right? We want to use something like AppDex scoring, right? Love it or hate it. It's a basic scoring template that just tells you how often users are frustrated with the load times or tolerating the load times. And you can customize like what those load times are. It's usually under 2 seconds is okay. Over 2 seconds or 2 to 4 seconds is frustrated, and over 4 is, an angry user. So understanding that from a long-term perspective, right? Baselining this over time, that can be really helpful. overall network capacity, and here mean opinion score. And the reason I bring up mean opinion score is that's a voice metric, right? That is specific for voice or video type apps like the ones we're on today. Data traffic and voice traffic, it responds very differently to network issues, specifically to things like voice loss, and voice jitter is different than data loss and data jitter just because the network is going to impact those packets differently. We're using different packet sizes, different spacings, and so understanding how those are impacted is going to be really important. Okay, so we also want to look at regional impacts. We want to isolate differences in geographies and understand the kind of expectations of performance across those global regions. That'll help. And then we want to set targets, right? Alert thresholds or common kind of metrics that we can kind of look at and say, we think these are going to go up, down, or stay the same, right? So the key metric here I would think about is mostly loss. Latency is going to be one that is going to be different for regional, but loss should be generally pretty good. We often say over 2% is bad. And obviously with loss, it's also the longer it goes on, the worse it is, just because, TCP and applications are often fairly resilient in the sense of guaranteed delivery. So I showed you this SLA chart already, right? But this is where you can compare locations and isolate when issues are kind of local to one site. And then you can also report on SLAs from a grouping perspective. So in this case, like grouping your ISPs to understand how ISPs are impacted or how offices are impacted by different ISPs and kind of what their focus is or what you should focus on for a violation perspective. So again, I'll swip over to the demo and we'll look at the baseline. So here I just switched to a different dashboard that's just showing a total location. And this one's actually going towards SAP HANA, so a database provider, and we're doing the same thing. So now I can see that this location, this office actually has some problems. And so this might have been going on for a while. It might have been a known migration issue. Could be, things like, firewalls and things like that are preventing applications from getting there. So this could be a misconfiguration. But if I just focus on my other cities here, I can see Las Vegas had some problems in the middle of the month, Denver in the early part of the month, and Paris is pretty good. So I can understand that this application, or in this case, the service, database service, is actually working quite well. From the SLA perspective, this is a great one because this shows me a long window of time before the migration, and I can compare this to after the migration. The other thing that I showed in the slides that I want to focus on is I want to do this from not only an application perspective, but also a network perspective. And so this case, I'm looking at the violation duration. So again, alarming and how long is it alarming? And then I'm plotting that onto this to figure out which ISPs I'm having the most trouble with. So in this case, I can see Zayo is actually my biggest problem. And I can click into there and say, okay, these are all Vancouver ones. So it's actually the Vancouver ISP that I have a problem with. And I can see which applications might be impacted by that, right? So if we're baselining experience, we're doing it not only from the application perspective in that first dashboard, we're also doing it from the network perspective. And by having both before for long time windows, right? This is just showing 4 hours, but I can bring that up to last month, this month, or the last 30 days. I can understand generally what good looks like from the performance perspective. All right, let's jump to tip number 3. So proactively monitoring. So we've established, right, benchmark with our baseline. The hard work actually begins when we start doing this. So at this point, we're starting the actual migration. This phase is pretty stressful. It's most of the disruption that happens is going to be during the kind of the start of the migration. But if we're doing proactive monitoring, the first thing I want to say is, what is proactive monitoring, right? When we think of basically traditional tooling, we think of them as generally in number 2 here. So reactive monitoring. It's passive collection of data. So the user has to be impacted for us to be able to see the problem, right? So if the user is impacted by an issue and we collect it, at some point in the future, we'll be alerted that issue may have occurred. Then maybe you get a ticket about it and you can go back and look in time based on what data you have. But We also have a lot of problem with that, because if you're reactive, that means one, you're kind of always scrambling behind tickets, and two, you start to lose the credibility of the IT or the cloud operations organizations, because people expect you to be on top of this and you to be ahead of it. And so proactive monitoring is really what I'm talking about here. And right, it's looking at if performance is degrading, we know immediately, often within seconds, because we're testing all the time, that there's an issue, and we can start to be on top of it, right? Who hasn't had an email from their office that said, hey, we're aware of this issue and we're working on it, and just felt better about that organization than having a problem with an issue or with an application and then having to go tell IT or your network operations team about it to say, like, hey, I'm still having an issue with this. I thought you guys were working on it. Right. So I'm showing the network observability maturity model. It's just the steps that we go, right? After proactive, we want to get predictive. That's a little bit in the same vein of, once we know what normal looks like, we can start to see when we're trending in the wrong direction. And that's where we start to get into the predictive side of this, which is great. So if we're during the migration, right, we started the migration, now we're kind of during, the key metrics, right, that we're really focusing on is we want to verify that the current environment is ready for the transformation. We want to mitigate, negative effects on end user experience and measure the end user experience beforehand. But we also want to measure it continuously during this process, right? So we're going to continue to monitor the same metrics and kind of eliminate any surprises by the end of it, because we're going to see them as they happen. We get that immediate feedback, right? We're implementing ways to get that user feedback as well during this migration. And then we're looking for success reporting. We're looking at ways to communicate progress throughout the process. And so that we can basically say, hey, we've just migrated, these 3 parts, phase 1, phase 2, whatever, and we're still seeing good user performance, or we're still seeing no impact to user performance, which is the key here. Key metrics that we want to look at, AppDex and Moss. I've mentioned both of these before. AppDex for applications, so looking specifically at which applications are generally, still performing well. In this case, just again, showing Teams. It's one of the more latency sensitive and the ones that more people complain about. And Moss from the network perspective, mean opinion score from the voice metrics, right? Gives you a general idea of how voice traffic would transit a network, right? So one of the scenarios I wanted to kind of bring up here is just a real life scenario. In this case, it was an MPLS cutover, but it was also part of a cloud migration that they were doing. Customer had started to migrate applications, workflows to the cloud. Many of those applications were latency sensitive, and with healthcare, you're not only talking about doctors and nurses being impacted, but eventually you're talking about downstream patient impact. And so being able to monitor the cloud environment, really critical to them. And the customer was in the process of performing this kind of WAN transformation between. As they made this transition, they were doing it off hours, and all of a sudden saw their capacity drop as soon as they changed. They were able to roll this problem back. So when they saw the capacity drop, they were able to look at spiked. In this case, you can see data loss, jitter, latency, RTT were all spiking at the same time. It's basically, they were told that they were going to get the 1 gigabit per second, and they were getting only about 200 in this case. And so the change highlighted an issue with the MPLS provider. They were able to roll this back because they were able to identify it immediately. It was done after hours, so no one was actually impacted this in the morning. Basically, with the healthcare, a lot of the stuff overnight is going to be, critical services are on-prem. But if it's, something like data warehousing or, scans, things like that being uploaded, all that stuff can happen, overnight if it's possible. If not, then it will happen during the day, but you don't want to impact the networks as people are using that as much as possible. And so this is an example where catching it immediately allowed them to kind of roll it back, have the discussion of what the issue was, and fix it so that the next time they kind of went and did the change, they were able to verify with the MPLS provider that they got what they needed for capacity. So just an interesting kind of catch that we were able to see pretty much immediately when this happened. So with this, I will go into the next demo. So we're talking about we're talking about basically the proactive monitoring. And so as I open that up, And I'm just logging back in here. And let me grab that one. Okay, so there we go. And so in this one, I'm actually looking at proactively monitoring from what we call an N10, which is basically a laptop base connection. So similar to what I have on my laptop. You can probably actually see the Appneta icon in the top corner here. And this is going out to work from home monitoring. So basically testing out to basically an endpoint that we have to specifically look for what the performance of a work from home environment is. And so one of the things that I can see is I can see from the environment, I can see that they go out to Verso network, and in this case, going to GCP for the endpoint. I can see changes in their actual capacity. I can see in this case, that their utilized capacity dropped. No data loss associated with that. Jitter is generally spiky, but not too bad. It's pretty low. These black bars are your alert threshold, so we're not violating those from latency or round trip. You can see voice, we actually did have a problem a little bit ago. And so understanding when that's happening is going to impact things like a Zoom or this type of conversation. But what we can also do with the wireless is, we talk about this, active monitoring where we're sending test traffic out. We also have a lot of the passive stuff. So if you're on wireless versus wired connection, we can look at signal strength, link speed, RSSI, right? We can look at the actual host metrics. And so if I click on one of these spikes and I saw one of these spikes persist, then I'd be able to say, oh, from that user's perspective, and it was just load it here, and that might be a little bit slow right now. But I can see that Symantec probably was running, an endpoint protection scan. Right. And so if that persisted, I could tell them, okay, well, if you're going to, run a Zoom or if you're running a webinar like I am now, maybe we pause that for a second and bring that back online after. Not everyone's going to be happy about that. I know security is very important, but you can also see they're running a lot of test traffic. So maybe they were configuring something from their monitoring point that was causing the issue. But I can go back in time and I can see how this is affected. Very effective with work from home users that you've told to be on wired connections, and you can see them switch from wired to wireless throughout the day. So being able to understand what they're doing may be able to get you away from something that said, hey, I'm having an issue with this service that is part of the cloud migration, but this is an unrelated issue. This is a separate issue. And so that's the core part of this is if you're going to be proactive and run this continuously, then seeing this stuff can actually prevent people blaming your migration for something that actually wasn't its fault. So let's go into tip number 4. Validate migration success using objective metrics. So we've established the baseline with tip 1. We've proactively monitored during the move with tip 2. We've established we need a proactive stance. Now we arrive at the crucial moment of proving the migration was worth the effort, right? When we actually validate migration success, right, we move beyond subjective feedback like the app seems faster or, it seems okay. We're looking at actual metrics that matter. So from the application performance side, we're using the same synthetic transactions that we used in the baseline phase, right? We're showing kind of end-to-end transaction time in the new environment, right, compared to the old. And we can prove that, the critical business workflow, service, or application is now faster and more consistent, or just equally performant, right? Sometimes it's just proving that we haven't impacted it. From the network perspective, we're validating core network metrics like latency, jitter, packet loss, making sure they're within acceptable, baseline or norm, or maybe even improved. And so this data is what actually proves that we're successful, right? It's, validation isn't kind of this one-time event either. It's an ongoing process, right? Once we validate the migration, we pivot towards the continuous monitoring stage where we're trying to continue to show, over the next few months that we're actually, not impacting it from a long time. Because we all know that oftentimes issues are not persistent. They're going to change over time. And so we want to make sure that we're kind of proving that over time as well. And so let me just open this up. So afterwards, when we're doing our continuous monitoring, we're doing it for SLA validation. We're also looking at it from the business reporting perspective. So that's why you're seeing a lot of these SLA type charts or full charting. We want to do this because it's not only the mean time to resolve, it's also the mean time to innocence. And if you haven't heard that, it's really about proving that it's not your fault, right? That is one of the number one things that network teams have to do, is prove it's not their fault. And so we want to reduce the mean time to innocence. How long does it take you to prove it wasn't something you did? And so having objective metrics, having metrics like data loss, from before and after and over time can really help prove that. And this is where the service quality report does well, because it can show you, first of all, that there are no outage violations, or very few outage violations in this case, and that the performance validation is quite good as well. And so we want to make sure that we're spending the time to gather that data beforehand so that we can prove the success at the end time. And so this is where I want to put in a little plug if you're one of the many customers of ours that's migrating towards VCF. Appneta and largely Network Observability by Broadcom, which is the solution name of DX NetOps and Appneta together, which is our data center and our WAN technologies. Network Observability is an advanced service for VCF9. It's essentially, if you don't know what an advanced service is, it's essentially other divisions or products within the Broadcom suite that the VCF team is actually deemed valuable for their customers and spent the time to validate. Many of these teams are working on integrations or have integrations with VCF. And so as you're moving to VCF 9, or 9.x, really whatever version, it's one of those things that we can provide additional value outside of it, because we know many people are in this hybrid type scenarios. And so our core focus really is around optimizing the network operations, right? Focusing on understanding that end-to-end path. As we've mentioned, you can see a version of our kind of, our error domain chart up there as well. We want to accelerate network transformations like this one, our cloud migration story, and we want to enhance connected experiences. We want to make sure that, one, they're better because you are proactive and understanding what's actually happening to the user, but you're also looking at it from the end user perspective. So that's just a little pitch for anyone on the VCF side. And a lot of this, from the migration success point, I just want to pop over to the demo again. So when we're talking about success, I'll actually go back to these dashboards here. So these quality dashboards, really helpful in the performance violations as well as the outages. If I go into the other one that we had that was specific to a specific application like SAP HANA or service in this case, right? I can tell you how long we've had no monitoring in place, right? How often it's violating performance, and I can do that per location. And so that's really where we get the core part of this, where we say, okay, if we have a problem, I can click in and I can say, I know this one is probably not a good example just because it's been out so long. But if I click into that, I can not only go back in time and see what the performance has this been, but I can see also what route it's taken. All right. This is the most recent route. It allows me to show a bunch of different data. And now, of course, I'm having a little bit of issue just loading through the internet, probably while I'm also uploading the video here. But again, you can go back to these dashboards. And here we've got our network stuff now. So capacity, I can look at data loss. You can see this is a very spiky one. This might be on purpose in our demo environment. But you can see things like event summaries for this is measured data loss, 649 to 7. So a pretty long data loss, elevated data loss in this case. And you can see from this perspective, we don't have voice apps because we're going out to SAP HANA. So it doesn't make sense to have voice metrics. We're just looking at data metrics. But when we have these kind of issues, if we look back over time, we can see every route change. We can see when we've gotten diagnostic tests, different violations. We can see when the monitoring point has been, offline or when we've updated it, right? We can see if there's an ISP change, right? When I go back into our network paths and look at multiple network paths, I can also walk that timeline back in time and actually see when the route changes. And so if something happened 2 hours ago, I can go see what route we were taking 2 hours ago and look exactly, kind of when that, if that route change actually connects to when I actually had an issue. All right, so we're gonna go back to our last tip, and that's use synthetic transaction monitoring. So, we've migrated, we've validated, job's not over. final piece is really about kind of looking at experience over time using synthetic transaction monitoring for applications and synthetic network monitoring for the network side. And we're going to keep those running 24/7. Right? We're simulating user workflows across the cloud environment, again, public or private. And we're really looking at it from an early warning system type of sense. And so we're trying to understand, we're kind of consistently checking the performance of most of these, but we're trying to understand what, again, normal looks like and what health looks like for these applications. And it's going to be different, again, based on geographies, but also based on the application and kind of the resiliency of that application. And so from the AppNeta perspective, right, we feature synthetic monitoring. It's through two different types. So we can do Selenium scripts that emulate the paths and actions of an end user. Those are going to be very easy to write and kind of set up, and actually getting easier in the future as we kind of bring in AI to kind of help write Selenium scripts for people. We also have the way to do kind of HTTP curl tests, right? To understand, just like if API or a service end is your core focus for an application, we can do that as well. And this is really to accurately report on kind of application status, right? So we use AppDex at the top there just to give you a general sense of the application, but you can also go all the way into, network server browser breakdowns, all the way to a waterfall chart, right? So just a note kind of about AppDex, right? It's a performance element above and beyond availability. It's a little bit better. And this is based on the Selenium script. So it's based on all the steps you do. And we often talk about single page applications in this sense, because if you just test to the front door of an application these days, you're probably just testing the login page and whether or not the page loads. That's not the application anymore. The application is behind that door. And so you've got to log in, you've got to click around, you've got to create and delete things, usually in a service account. But that allows us to understand what the health of the application really is. And AppDex does take all that into account, because it's how often does that script basically complete. Excuse me. Right? So if we're doing that over time, we're not just getting an idea of the health of the application or the health of the front door. We're getting a health of the entire user workflow, right? And so we're using AppDex across this to give you that granular insight. From the other perspective, when we do our web testing, we do enhanced web testing. So we do everything: redirect, lookup, TCP, SSL, request. All those different steps are going to be represented, as well as the milestones that you've created. And so that's one of the big pieces that we want to be able to do, is basically click all the way through every part of the web transaction, right? So let's see. I think I'm going to jump right to the demo on that, just also aware of the time. But if I go to the web timeline page here, right, again, this is a Denver based device going to googleapis.com. So this one is going to be just a basic web test, right? And so the web test is going to do all of these steps. So the redirect, lookup, connection that I just mentioned. It's going to look at retransmissions of TCP, right? How often does that happen? Download, and it's going to look for DNS response. You can indicate additional servers to also find out if a good response is masking other parts of a cluster, or another response that is bad. So you can see if one is, constantly higher response time than others, maybe a bad configuration on one of the clustered machines. Or you can look at, which one of your providers, because oftentimes we have multiple, which one of your providers is actually providing the best response over time. Right. So this is an example of just a simple HTTP test where we're getting all of this data. We can also look at the web timeline and look at something that does something beyond the page. So Google sign in, does the login, goes to mail, goes to drive, right? So we can see a breakdown of what's happening with this one. In this case, we can see two steps, but so the other two aren't working. We'll come back to that in a second. So we can see that we're getting pretty far into the communication. We can see we have some problem with download here. We get those same metrics for redirect, lookup, all that. We get the same download metrics. We get AppDex, and we get DNS. But if I go all the way back into the top and I actually click into this, I'll be able to see the full waterfall breakdown of this and a screenshot of the error. So in this case, the web script might actually have to be updated because it's going into an SSO, or sorry, a single sign-on connection. and it's getting stuck at that step. And so whatever the selector for the password is not actually popping up, because in this case, the app might have updated and now it does username and password on 2 different screens. So we can use that to go update it, or we can use it to see if there's an actual issue. So here we can see the entire waterfall breakdown. And so we've got all the data we need from the experience perspective to understand that component. And with that, let's jump over. It's our last demo. So finally, key takeaways, right? We want to start with baselining. We want to understand what it looks like today and understand normal. That's going to be one of the biggest things to de-risk, not only the actual migration itself, but your ability to prove success of the migration. Then throughout the migration, we want to migrate and monitor it. So we want to make sure that not only are we making the changes, but we're updating our monitoring to basically collect the same metrics or get better metrics as we go forward. In this case, I'm pointing out VCF, but others make sense. And then we want to validate and then assure continuously afterwards. So by continuously simulating it afterwards with things like experience, being able to understand what good looks like even after your migration is going to be critical to proving success, and also critical to basically showing the expertise of your team within the organization, but help you kind of put the bow on that full cloud migration. So when we're talking about de-risking, it's really about the work you can do up front in order to prove and help you succeed later. And with that, I will say any other components that you need from us, networkobservability.broadcom.com is your place to go. And I will send it back to Doug for any Q&A.
Yeah, I want to get your take. So obviously at Solutions Review, we see a lot of solutions. And we've seen a lot of them over time. And from a vernacular standpoint, I want to get your take on where you make the delineation between network monitoring and network observability as people think about this in context.
Yeah, so again, an analyst is probably the best person to ask for that, because they're, I think, the ones that really drove that change. But to me, network monitoring is the idea of passive monitoring. It's collecting the data that's already there to understand what the network is doing. And I think observability is taking not only into account the ability to send more data out to actively monitor it, but it's also taking more of that data in context with everything else that is happening. All right. Network monitoring tended to just focus on, okay, I'm monitoring, the network device health and understanding what that looks like. Still very important, but doesn't take into the context the end user that's transiting to an application that doesn't care about the network health at all. They don't care that the network has problems or the network's overloaded. They care that they get to an application. And so the context of the application is important. And I think the other part of that is that most of the time we design networks to function, to send traffic, to be able to handle, more gigabits per second of flow. But now we need to design them to be observable, right? And that's the focus of actually putting in hooks into our devices, into our virtual environments to understand and be able to send back data to help us understand performance and kind of visibility. So it's more of the evolution. It's not fundamentally different. It's just the evolution of kind of networking in context of everything else that's going on.
Yeah, and the evolution that you just showed with regard to synthetic agents, for all intents and purposes, kind of probing apps and kind of reporting back is clearly getting to that next level. But I'm also curious, because everything comes with the trade-off. What is your take on the potential for alert fatigue when there is so much happening that can be observed? It's almost as if you can observe so much and capture so much data that you're almost creating your own cloud storage challenge just from the log files and the activities. Where do you see? I mean, being in the business for so long, where do you see the kind of barrier reached with regard to how much needs to be reported?
Yeah, I think with reporting, one of the things that we need to do a better job, especially as you mentioned, there's way more data today. We are working on this, and I think every vendor is probably working on this equally. I'm going to use the buzzword is using AI to kind of parse some of this. That's one way to do it. I think what we're doing right now is actually, training our models to be better at identifying what is, noise and what is signal. And I think the signal to noise ratio that we've run into with the kind of growth of the amount of data that we have is, as you say, it's unsustainable, right? It is outpacing the ability for humans to understand it. And so the focus that we're doing is bringing all our data in context, right? Reducing red flag or, kind of red herrings and things like that. We're essentially crushing down any alarm or error that is now based on the knowledge of the topology of the network, anything that's upstream or downstream of the error, depending on what type of error it is. And so if we're looking at alerts or faults, we're doing a full suppression engine on that right now. That's, kind of before all the AI stuff. It's already in the product, but it's about kind of noise suppression and understanding that, if you have, millions of alarms per year, if we can bring that down to hundreds or thousands, and only bring the ones that actually matter, right? That, hey, this device is down and that's causing these 10 other alarms, and we suppress those alarms, then that's the one you actually care about. Like that's what we're doing today. And it's only going to get better as we train our models to kind of recognize. And I think, again, it's based on that context. So if it's in the context of the topology of the network or in context of what's upstream and downstream, then that's kind of the only way that you can do it today.
Yeah, and I love that take, the idea that you work with an organization like Broadcom and AppNeta to sort it out in the here and now, but that you're also thinking about how it can be handled, because the alerts are important. They just can be overwhelming. Yep. How it can be handled in a more automated, potentially using AI manner. So I think this is great.
Yeah, we know that network operations teams and cloud operations teams aren't quite ready for full automated remediation based on some AI, but they are willing to let AI do a little bit of number crunching so that they can present better information and let the human make the decision.
Well, and I think that's how it'll probably evolve, that kind of human in the loop. And then, after you kind of reach that comfort zone, you start to, let go of some of the things that you're comfortable letting go of. And I expect that to go very fast, actually. And I'm sure it'll be driven very much by all the things you're doing, because ultimately this is where the technology is headed. This is what I think people expect. I think people are going to expect these, whatever you would call them, observability agents, to be not only doing the synthetic testing that you described, but also to be handling a lot of the aggregated alert, determinations.
Mm-hmm. Yeah, for sure.
So somebody's looking at having a call. They've watched a show like this. They're thinking, I need to get in touch. What is their best step, and what can they expect in terms of having this conversation? How does it typically go down?
Yeah, so our focus is always about understanding every kind of customer use case and kind of understanding what exactly they need to do. I mean, we work for Broadcom. We have a lot of different solutions. We want to make sure that you get the ones that you actually need. And so if we look at, networkobservability.broadcom.com, there's a way to request a demo through there. You can email me. It's just alec.pinkham@broadcom.com. Or we can kind of go through, other official channels. If you're already a customer and you want to connect, then you probably have an account manager that can bring an internal place. If you're a VCF customer, you can just ask about AppNeta and they'll get someone on the horn from our side. So it's a pretty seamless process, but honestly, it's I think that website's probably the best bet, or just reach out.
Well, and I would encourage everybody to reach out as well. I mean, you never go wrong. These are not predetermined pathways to a sale. You never will go wrong talking to, industry-leading solutions like Broadcom and AppNeta. So, and experts like Alec. I mean, he just gave me his email address. You want to jump on that?
Go for it.
Alec, thanks very much for the time today. Great demo, by the way. That was very well segmented out, easy to follow. Lots of really interesting information. We really look forward to being able to put Broadcom in the spotlight again in the near future. But once again, thanks for being with us today.
Thanks for having me.
Well, there you have it. Another solution in our spotlight. We want to thank Alec and Broadcom for that presentation, and we appreciate your attendance as well. Until next time, I'm Doug Atkinson here at Solutions Review. Thanks for watching.
If your business would like to be featured in a future event, contact us today.